Hello students, welcome back to the lecture series on Introduction to Scilab Software. We are solving question set 11 and this is video part 12. Let us start with finding the inverse of the following matrix. Now, before finding the inverse, let me tell you that not every matrix is invertible. That means it is not necessary that inverse will exist for a matrix. So inverse exists when the determinant is not equal to 0. So I just want to take one example where I want to show that the inverse does not exist. That is why we are verifying whether inverse exists or not, and then we are going to find the inverse of the matrix. Suppose you have taken this matrix and the 0 0 for example. So let's find the inverse of this. The command is inv into bracket a. So problem is singular. So why we are getting such message is that matrices whose determinant is 0, the inverse does not exist, and such matrices are called the singular matrices. And for the matrices whose determinant is not equal to 0, it may be a positive or a negative real number. At that time, the inverse exists and matrix is said to be non-singular and invertible. So before finding the inverse, it is always necessary to find the determinant of the matrix so that you can see the determinant is 0. So we can write that determinant is 0, the matrix is singular and the inverse does not exist. So it's always better that we use this thing, that before finding the inverse we find the determinant first and then find the inverse of the matrix. Let us declare the first matrix, which is -2, -7, -9. Then we have 2, 5, 6. Then we have 1, 3, 4. This is the matrix first. Let us find the determinant. So determinant of this matrix A is 1. So yes, the inverse exists, and inverse of the matrix is INV of A is equal to this. Now what is the inverse of a matrix? Let me tell you, if you multiply A star INV of A, so you're going to get a identity matrix of the same order. So this is identity. This is the definition of the inverse of a matrix A. The determinant should be non-zero is the condition, and inverse means A into A inverse is your identity matrix. We are not going to verify it for each and every example. Now the next, you can see it's a matrix of order 4 by 4. So let us declare like it. Let us take it as B, which is 4 0 -7 -7. Then we have -6 1 11 9. Then 7 -5 10 19, and then -1 2 3 -1. So this is the matrix B. Then let us check the determinant. Let us check for the singularity of the matrix. It is of determinant 1. So INV of B is this matrix. Now the second question is, A matrix is given and we have to find second column of A inverse and third row of A inverse. So let me tell you, if A is given, let us take the A. In the previous session we have did this, that if you want a particular row or a particular column, so for inverse also we can do that. It is not necessary to store it somewhere and then call the function. What we can do is -1 5 -6. This is 5 -4 and 7. So this is the matrix. Now if you want to find a second column of A, for example, so what was the command? Second column. So first column will be there and then the column number. So this is for A. If you want to do it for inverse, you can write INV, then INV of A, and then in the next bracket what you can do is you can write the second column, that means colon comma 2. So we don't know the inverse of the matrix A, but we know the second column of the inverse. Here you can also verify inverse of A is this. So second column is the same as we got. Now third row of A inverse. Third row of A inverse. For the row, what we do? We write the row number first and then colon. So this is the third row of A inverse. Now let us go for the last question. Third one. Let us declare the A matrix. Okay, it is there already. We have declared this matrix in the question number 1. So let us extract this from there only. Is it the same? Okay, this is -2, -7, -9, 2, 5, 6 and 1, 3, 4. And the B matrix is, let us call this A, and the B matrix is 1, -2, -1, -1, 5, -6, 5, -4, 7. But let us call it B matrix. These two matrices same we are using in question 1 and 2, and the same matrices are there in the question number 3. So A and B are there. Let us verify whether A into B inverse is same as B inverse into A inverse. So inverse of A into B, so no need to find the product of the two matrices separately. We can write inverse of A star B, this. Then let us find inverse of B star inverse of A. So these are the same. We are asked to verify the fact, so we can write in the comment that yes, it is verified when we are solving examples for the examination. It is verified that A into B inverse is B inverse into A inverse. So this way we have completed the concept of determinant as well as inverse. So for these questions, for third question, we haven't verified the determinant first because we have to verify, so no need to verify whether the determinant exists or not. Let us meet in the next lecture. Thank you.